Hi students, let's look at this question here, which is on functions. It's taken from the year 2016 ACJC promo question 8. So you can do this proficiently. So a student defines a function f when its inverse function by the following: sine x is between minus pi to pi, and after which you have f inverse, sine inverse, which is the f inverse of inverse, not really the inverse function, but the inverse of this, as this. Okay, with the A diagram, explain what is wrong with the definition of f and suggest a suitable restriction to its domain such that the definition of f inverse is correct. Okay, so the first thing is try and understand how do we actually sketch sine inverse minus pi to pi. So just use your calculator here. I'll suggest just key in, just bring out a calculator, and we're gonna just clear this. Okay, I'm just gonna plot the sine inverse here, sine inverse x, okay, and I'm gonna use minus pi, negative pi to pi. Okay, it's a graph which we've learned in secondary school before. So in this case here, 5 to pi, close it, and we're just gonna graph it, and it will look like something like that. Oh, am I right? So this is sine, not sine inverse. Okay, so maybe I just zoom standard first, and I'll just gonna zoom square, zoom box. Zoom box will be roughly here, to here, to here. Okay, so just enter it, zoom box here, zoom square. Okay, so this is the graph here. Now, with the aid of a sketch, so just sketch this curve here. I think this is pretty okay. This is a sketch here, so we know this graph here as y equals to fx, where this is actually just pi, comma 0, and this is 0, 0, and this is actually just minus pi 0, and this is obviously pi over 2, 1, and this is minus pi over 2, negative 1. Okay, so we have all these points here. You know that this graph here, by the horizontal line test, the line, actually the line here, okay, just write it down. So the line y equals to 1, y equals to a half, cuts f twice. Okay, hence f is not a 1-1 function. Okay, thus f inverse doesn't exist. Okay, so that's, you just use the horizontal line test here, you just cut it here. Using half here, you realize that actually it cut twice. So this is not 1-1, obviously, and we just need to make this 1-to-1 function. Now then, after which we look at f inverse, sine inverse. So suggest a suitable restriction to its domain such that the definition of f inverse is correct. So I'm just gonna draw this out for you. So sine inverse graph will look something like that, inclusive of 1 and negative 1. So I'm just gonna put divide. Just put it negative 1 and 1. The domain here, actually just a sine inverse graph here. Okay, so if you look at this graph here, actually what we want is just this part of the sine graph, which is actually this part here. Okay, so from -1 to 1 here, we just want this part, because when you reflect this part, you'll get the red part here. Okay, this red part corresponds to this part here. Okay, I hope you can see. So this red part here corresponds to this. Okay, so because we are just told to suggest, I'm just going to suggest for the domain, this would just be, there you go, this is why this is important. This minus pi over 2, and this is pi over 2. So the domain, the suitable domain, maybe I just move this aside. Hence, suitable domain is negative pi over 2, pi over 2. Okay, so this is a suitable domain. Just remember, that if this is pi and 0, this the maximum point is half of it. So that's why it's minus pi over 2 to pi over 2. Okay, so that's how you do the first part. Once done, we're going to look at the second part. The function g is defined by this function here, minus 1 to 0. Find the inverse function on g inverse in similar form. Okay, so I'm just gonna sketch this curve here. Function g will just be just have a sensing of what graph is this. E to the power of negative x plus 1 square, and the domain is from negative 1 to 0, so negative 1 to 0. Okay, negative 1 to 0 there, and just gonna graph it. And it's here. Alright, so zoom box. As usual, I prefer to just zoom inside here. So it's, here you go. So this is the graph here. So trace negative 1, this will be 1, and trace 0 will be, okay, it's just e to the power of negative 1, right? So just graph this out. Find the inverse function in similar form. So let's do this. Part 2. Let y inverse function, meaning we just want to make x a subject here, and just ln both sides. Y equals to negative x plus 1 square. This will be ln y equals to x plus 1. This will just be plus minus negative ln y x minus 1. Okay, square. Okay, so that's about it. We are going to just express this. So it's x equals to minus 1 plus, okay, this negative looks very ugly here, so I'm going to just y to the power negative 1 or negative 1 minus ln y to the power negative 1. So essentially this negative just bring up, right? So there you go. Once you're done, we need to decide from the x here. This is minus 1 to 0. So minus 1 to 0 would be this, right? So just reject. Okay, as x is between minus 1 and 0. That's what we have to do, right? So we because it's minus 1 minus of a number, negative 1 minus of a number, if you take minus 1 minus of any positive number, you will get anything less than negative 1. We want it to be minus 1 to 0. Okay, so in other words, hence f inverse x is just negative 1 plus ln 1 over x. Okay, the domain of this case here, domain of f inverse is the range of f, because we are told to write in similar form. So meaning we need the domain here. I'm going to just write this down. This is where x real value. The domain here will just be from this point here is x0. When x is 0, this is when x is 0. This point here, x0, y equals to e negative 1, which is 1 over e. So this is actually 1 over e. And we just now we found that this is 1. So this is 1 over e. So this is inclusive of 1 over e to 1. So in other words, this will just be 1 over e to 1. Okay, so I think that's about it for the first part. Should be quite okay. Should be quite okay. So let's look at part 3. Explain if the composite function g inverse f inverse exists. For g inverse f inverse to exist, for g inverse f inverse to exist, okay, just remember that the first function is this, because this is the first one to touch x. The range of the first function must be contained with the second domain of the second function. Second function called x. So the first one has to be able to shoot within the means of the second function. So domain of, so we can write down range of f inverse. Range of f inverse is the domain of f, which is actually minus pi to pi. Okay, it's not minus pi to pi because it suggests a suitable restriction here. So I am going to use what we found just now, which is minus pi over 2 to pi. I think the question is not clear. They should tell you that to use the domain of the one that you found just now. Okay, so I say for the rest of the question, they should write that should just take this new domain here, which is minus pi to pi over 2. After which we're going to look at the domain of G inverse, which is actually what we found just now. It's 1 over e to 1. So the second one will be the range of F inverse cannot contain the domain of G inverse. Hence, G inverse F inverse doesn't exist. Okay, because this is about 1. What is this? This is about 1.57. Okay, so this the domain of G1 cannot, G inverse cannot contain it. That's why it doesn't exist. All right. Let's look at the subsequent one, the last one, which is write down F inverse GX. Okay, and its domain, find its range. Okay, so we're gonna just find for F inverse G inverse X. This will just be G inverse will be here. We found G inverse, right? Okay, G inverse in similar form. So this is G inverse. This is G inverse. Sorry, I wrote this as F. Okay, so G inverse in similar form. I'm gonna write this as F inverse 1. Okay, and F inverse will be this function here, which is sine inverse. So this is actually just sine inverse ln 1 over x minus 1. Alright, states its domain. Domain of G inverse is domain of F inverse. G inverse is the domain of first function, which is domain of G inverse. In this case here, the domain of G inverse is 1 over e to 1. Okay, so it's here. All right. Then the range, however, is a bit tricky. What we need to find is essentially find the range of G inverse to put in the domain of the F inverse. F inverse. Oh, this is a bit it's a bit tricky. Let me think. How do we explain this part here? So this part here, sorry, let me just write this as 1 over e to 1. So the range of F inverse, we need to take to find the range of F inverse, we need to take the range of G inverse, which is actually the domain of G, and we need to put into the domain of F inverse, which is in turn the range of F. Okay, but okay, let's not confuse ourselves. So range of G inverse is actually domain of G, which is actually what we found just now. Domain of G was given, right? Minus 1 to 0. So this is actually negative 1 to 0 here. Negative 1 to 0. So I'm going to fit this into the domain of F inverse, which is actually the domain of F inverse. Okay, the F inverse graph looks like that, right? We know that F. So I don't want to introduce too many inverse function here and so on. So I'm just going to use this graph here. So it looks something like that. Zoom in a bit. So it looks like that. Okay, so this graph here, let me just draw it out. So y equals to sine inverse x. This looks like that. This is minus 1, this is 1, this is pi, and this is negative pi. Okay, so I'm going to take negative 1 to 0 and map into this domain here, inclusive. Minus 1 to 0 is inclusive, sorry. This is inclusive. Okay, so put this as minus 1 to 0 here. So what I get is here. Okay, what I get is here. So this case here, this is the essentially the range here is from 0 to minus pi. So this is the range of G inverse F inverse. So this will be, the domain will become minus 1 to 0. And after which this will map out the range of F inverse as minus pi to 0. So hence the range of F inverse G inverse is minus pi to 0. Okay, mapping function there. Oh, sorry, this is minus pi over 2. Okay, pi over 2. So this is pi over 2. My graph is wrong. Okay, so this graph, this is an inversive graph. It's pi over 2 because when we reflect, this is minus pi over 2 here. Okay, so it will just, it's just the inverse graph. Yeah. So if you draw it up properly, then you'll be safer, but I did not. So this should be pi over 2, yeah. Okay, great. So once done, hence or otherwise, when the verb of x such as gfe equals to 1 over e. So gfx equals to 1 over e. This will just be, you g inverse both sides. Just remember, when g inverse both sides, you will nullify this g. So this is fx equals to g inverse as such. That will be f inverse both sides. Okay, this will just be e. So this is x equals to f inverse g inverse e. So I'm just going to use a function there. Ln e, so this is sine inverse ln 1 over e minus 1 or plus 1 minus 1. So, oh, sine inverse ln here. Okay, so then I'm gonna just put this as this is minus 1 minus negative 1 or 1 over 1 over e. Okay, 1 over 1 over e. So this will just be ln e, which is 1 minus 1, which is actually just 0. Okay, so hence x equals to 0. That's how you do the last part, which is a more interesting one. So if any question in the comments, please let us know, and I'll see you in the next question.